Perfect.
Good afternoon, everybody. So welcome to, we're excited that this is the last session of LEARNeast. We're not excited that LEARNeast is coming to an end. We're excited with the great day it has been, and we know that this is going to be a great session. I'm Jeff Whipple. I'm a digital learning lead for Anglophone West School District, and also on the organizing committee of LEARNeast. And we're really excited. We couldn't make this happen without program partners, and I wouldn't say this too loudly for the other program partners, but Brilliant Labs is always our favorite ones to work with. They step up to the plate, and we love working with Jacob and the team down there, and they play such a great role in supporting teachers across the Atlantic region. So this afternoon, I'm excited to see this young man who's also co-presenting this afternoon. So Peter, it's been a long time since you were a student at Bliss Carman when I was there. So
I was at George Street back then.
Oh, you were
at George Street. Oh my gosh, sorry, I got that story wrong.
Back in like 7th grade, I'm pretty sure we had definitely had a few chats here and there.
Yeah, we've crossed paths somewhere. Anyway, it's great to see you guys. So we're going to talk about machine learning, way beyond me, but we're excited that you guys are able to be here. And I'm just going to let you guys go, and I'm going to go away.
Thanks, Jeff. All right, well, we'll get started. And this is one of the reasons why I love LEARNeast. It's an easy way to kind of get back into thinking about very complex topics, but not so complex that K-12 students can't not only understand, but also bring complex topics, tangible materials. Peter has done this with building a model for machine learning through image recognition in Scratch. And hopefully the idea is that we'll play with that a little bit. I was introduced to what Peter was working on a few months ago. It was amazing. The guy was taking a work hiatus with our newborn. The newborn wasn't taking work hiatus. I was. She was puking all over me. She's doing well. But anyway, this video popped up on my phone through Slack one day, and it just was Jeff Wilson saying, "Check this out." And incredible. And I don't know all of you listening know machine learning, and even preparing for this presentation. Peter, why don't we kind of discuss this together? Like you've dabbled with machine learning. How do you define machine learning at the simplest level?
So at the simplest level, it's giving data to machines and using math to make them do things that we want them to do, which doesn't sound terribly terrifying, like the media is trying to make us believe now, but that could definitely be a possibility. But I guess that's more of a scientific explanation of it. I think the way that
trying to counteract the feedback.
Sure, yeah, your voice has a bit choppy.
Okay. Yeah, Peter.
Yeah, but the way that I guess I like to introduce it to students, because I have tried many different methods with introducing the idea of machine learning, deep learning, making machines learn to very young kids from ages all the way back 1st or 2nd grade all the way up to middle school, and the way it is it's you're making the machine smart. You're giving it a brain, and that's the word I use a lot. The brain of the computer. This is how it's thinking, just like the way we do, because in many ways it's very similar. We look at the image, after we've looked at enough images of, say, a banana, we know that it's a banana and not an apple. So yeah, that's how I would explain it in kids' terms.
I love that call out to the internet fandom that is the banana. Somehow that's just, I saw a 3D print of a banana this morning with rules, like with markings on it of 1 centimeter to 12 centimeters. Everyone seems to be comparing the size of things that they print to bananas. So you're right there. I agree with you. My wife and I were. How's the feedback there? Is it fine? Can you
It's not great, but
It's not great. It's not. Stop talking. Peter, take us through what you've created.
Sure. I guess to do this, I have to go. We have time, right? We have another like 30-40 minutes. Yeah. So I want to just start with a bit of introduction on how we got started on this project, because this is I mean, obviously it's a hot topic right now, machine learning, but it is a curious combination of machine learning for very young kids, because now, you hear machine learning in a lot of places. That's not even in undergraduate level university. It's a lot of, master's, PhD programs, and you think it's something that's crazy complex. But for me, it actually wasn't that long ago that I was at school, middle school myself, because I just turned 19. So I just graduated high school a couple of years ago, and while I was a student in high school, I was in Moncton, so Harrison Trimble High School. I was working on a lot of projects on my spare time, and I first got introduced to those projects by my friend, and we started working on some programming stuff, and that led to research with Professor Engelhardt at the University of New Brunswick, and that's how we first got our hands on to using machine learning. And back then we were like 15 years old, we were 10th graders, and we kind of just played around with it ourselves in MATLAB, and we used the data that he gave us, and we created we were working on electromyography controlled prosthetics, so using electric signals from our muscles to control prosthetic limbs. And so we used that data and we created a classifier that was more accurate and just overall better in classifying whether or not something is is like the motion of the muscle from the electric signal. So that's how we got our start. And once you do that, you realize it's really not that much more complicated than it needs to be. And for us back then, it was just coding. But luckily, because of Brilliant Labs, the presence of which helped a lot in my middle school years, I didn't know how to program. I was programming JavaScript, C++ at the time, and I was comfortable writing code, and which is the medium of communication, as we all know, with computers. If you want to tell a computer to do something, it's almost like they speak a different language instead of English or French or German or whatever. They speak code, and you have to communicate it that way. And I was comfortable doing that. And later on, worked on some very interesting projects, with Dalhousie University and some research institutes on using machine learning image recognition to create a tool that helps medical laboratory technicians to classify images of acute leukemia, of blood cells essentially that were possibly acute leukemia, because that needs to be treated right away. And later on, worked on more projects on natural language processing, the intersection of mental health and machine learning. But I just want to say that it's an interesting project for me because I myself had the opportunity to work on machine learning from a young age, and Jeff, whom I met actually while presenting one of these projects at a science fair. It was a long time ago, but we kept in touch when we talked about this possibility, of finding a way to teach this to kids. I think this would be a very interesting project to work on. And it didn't all start out that smoothly, because when we first looked at this, it would have been about a year ago. So last summer, I did have a few courses. I had 2 courses at Brilliant Labs. So you guys had a summer program for students, a virtual thing during the pandemic where they could sign up for special interest courses. And I had a couple of courses that taught kids how to do machine learning, and it sounded really cool. Kids are super excited. We're going to learn how to work with machines, and I had a lot of people sign up, and mostly younger children, I find, because I'm not sure what the demographic is like here, if it's more middle school, elementary school teachers in this room, or possibly high school teachers. But what I found was mostly middle school kids that were interested in this kind of stuff. I think once they get to an age where I think that's middle school is the age where they're like primed to explore stuff. But obviously it varies person by person. So But that's what most of my students were. And I started out with something that I thought was simple enough. So I taught them how to do machine learning with this thing called Google Collaboratory, which essentially is like a, if you guys have ever written code before, you have to use, normally you would use an IDE, which allows you to run the code and, you know, has markup and that kind of stuff. And so I used Google Collaboratory, which I thought was it's essentially the same thing as Jupyter Notebook, which is what most people would use to do machine learning for most data visualization purposes. And I'm just trying to pull it up right now and show you guys this. And this is what they did. Let me show you. And it's not bad. It's actually pretty interesting. Oh, let's do this. Can you guys all see my screen?
Yeah, we can.
Yeah. Okay. So this was, I mean, so this was the simplest thing that I could think of. You know, this is the simplest way to me that I thought was getting into machine learning. You know, you're right. This was like what, like 14 lines of code, I think, probably a bit more. But that's like all the code they needed to write to classify the difference between two or more types of images. So it was like a 2-week, 2 or 3. It was a 3-week course, I think, 2 or 3 week. But it wasn't every day, so it wasn't that bad. But yeah, I started out first. I taught them how to. So I showed an example where I used dogs and cats as an example, and I downloaded images of dogs, I downloaded images of cats from the web, and I imported it using code into this platform, and I used. So this platform is just for writing. So this is just Python code, by the way, and I used Python to use this machine learning library called FastAI to load the images to train my classifier with with stuff like this, and yeah, and at the end of the day, it's able to figure out whether an image is a dog or a cat. And I had them work on their own projects from there on, and they had some really interesting stuff. I think one kid, he was really interesting. He was trying to classify different characters in Super Mario Bros. I think there were like 100 of them or something, but he never got to all of them. He was just a few. I think he got like 4 or 5. But yeah, but I'm just giving you an example here. This is the one I pulled up. Blue Jays and Robins. This was a project that someone worked on. I think he added a few examples, like other birds too, into it. I can't remember which one, like owls or something. But yeah, so it classifies different breeds of different types of birds using images that he downloaded from the internet, which was cool and all. And they had a fun time. And at the end of the day, this was a fun project to work on. And after they're done, I exported them onto a website that just had like 2 buttons that said like, upload image and classify it, so they could show their friends and stuff. But that was it. And I think the thing is, at the end of the course, even though they've created something cool and they're like, oh, this is machine learning, they have a good idea of what machine learning is, which is very good. And I'm definitely glad of the outcome. I think the thing that I was a bit, I guess, a bittersweet about is the fact that even though they created something like this, which is obviously really cool, it's mostly by following my examples and asking me, what do I write here, what code do I use here, instead of having the ability to do it completely themselves. It's almost like when you're learning a language, and again, using that as an analogy, when you're learning a language and you manage to learn how to ask for the price of something. If you're learning English and you just learn how much does this cost? You just learned this phrase, but you didn't learn complete. Like, you can't use this. You can't use words of this phrase in other contexts. You can't say a different phrase. This is the only phrase you know how to say. And even though you can get some success by going to the store and asking how much does this cost, and you probably understand the answer if it's just a simple number. That's the only scenario that you're able to use this in. Like, if you want to do something, if you want to say something else, all of a sudden you want to say, is this new or is this used, or where else can I buy this? Can I buy this online? You don't know how to do any of those things. And unfortunately, that is the case when they do something like this. we're talking about 11, 12-year-olds here at the max, and they've probably never written a line of code in their life before this, and yeah, they, when you just throw this in their faces, even though they are able to get something at the end of the day, it's not it's not, I think the perfect outcome would have been if they can really learn how to use the tools well as well. So a
it's
different
always
thing
important for students to be able to learn a new skill and then be able to apply it in the local context of their community and their classroom, using data that's important to them.
Definitely, and yeah, I just want to emphasize on what we said there, like applying that to their local classrooms and to their local communities and their classrooms. I think that's a super big factor of learning technology and engineering that's often overlooked in schools, especially. You go to, a lot of people, they go to like university and they study for 4 years, and at the end, they can't write a modular program at the end of it, like the 4 years, because they've just learned, like, they know the theory. You can ask them, they know exactly what to answer you, but if you don't have this hands-on experience, it's really different. And so having the ability to create another project. So for example, you say, oh, this is something, you notice a problem in your classroom, right? And I think now, Jacob, we have students in in Anglophone districts that are using machine learning to do some cool stuff, right? Like I've heard Jeff talk about a couple that with facial recognition or sentiment recognition, something like that. And if you're able to say, okay, this is a cool application, let's put a sentiment recognition thing in the hallway, and if it says is that you're not happy or you have a grumpy face, let's show a joke on the screen. So if you can think of something like that, not only does it cultivate creativity and innovation, it's also a great way to really solidify your skill. And that's where I want to get at here, and to really have that, give them the tools to do this. So something else that I taught to a different class last summer was building chatbots. This time, instead of using raw code, I got them to use IBM Watson Assistant. And this isn't really meant as a learning tool, I would say. I would say this is more of a tool that they use like in actual industrial applications. I have people that build medical applications with this. I know people that just general like websites that have like a help function. They want a chatbot to be able to answer the customer questions and stuff like that. But it is a bit different in the sense that it's not coding. Let me just show you guys what this is really quickly. IBM Watson interface. So if I go to like images here, yeah, this is kind of what it looks like. Let me make this bigger. Image, new tab. Oh, it's really small. Can we do better? Okay, this one's a bit better. So essentially, it looks something like this, where you have a list of blocks. We call them nodes in Watson. We have a list of blocks, and if it matches this block, it does this and that. So it's very similar to scratching that logic, that visual like block interface, but at the same time, it's not so easy that all of them can understand what's happening. But we're still able to make a few cool applications with it. Let me just show you one of them. I don't remember. I opened up this link from a year ago, so I don't remember what this was, but I'll say hi. And yeah, so they were able to train their own chatbots and give custom answers based on. So I guess for this student, he just put hi as an answer. Yeah, so I can ask for a poem, and it recognizes that you're asking for a poem. Ask a poem, and I think it's pretty smart as well. Like, it's just if you say something like that, it recognizes as well, not just the word. Yeah.
That's so cool. One of the things that intrigues me when you're using one of these systems for machine learning, IBM Watson or Google Collaboratory, you're not only using local data, you're bringing on hundreds of thousands and millions of samples of data from similar projects that the machine has already learned. And I'm likely simplifying the entire process. But let's say that, a student is using image recognition in their classroom to let them know if their pencil is sharp or dull. When they hold their pencil up, maybe it unleashes this magical pencil sharpener, right? It activates something to happen. But it's not only taking in the data that you, the person, the designer, has fed it. Perhaps it's searching the internet for all images of pencil sharpness that have ever been uploaded. Now, of course, I'm going to have to go Google pencil sharpness and see what kind of images come up. But that's one of the things that excites me. When our students begin to learn the power of data sets, they're ultimately linked to this global monstrosity of data that their algorithms their logical flowcharts can start to pick through.
Yeah, for sure. And I think that's just the way that machine learning is heading towards now. And the truth is, it's good to understand that theory, how it's being trained, but nobody does that now. So every machine learning startup or application that I know of uses some sort of pre-trained data set. Just because it's not. I mean, just going a bit more on the science here, it's not so much like just getting the pictures. If I want like a pencil sharpener, like you said, that's what it could do. Download all the pictures of pencil sharpeners. But what it really was, I think, at its core, what it's doing is it's learning the features, which is this part of the pencil sharpener. It's you have a part of pencil sharpener that's like a straight line. You have a part that's curved. You have this color, that color. It's learning those things. So it doesn't even matter what picture it's looking at. It just needs to look at a picture, and it's able to recognize these features and it's able to match these features together later. So really, it's just really just becoming smart as a whole, instead of matching, very specific things like pencil sharpeners or bananas or apples.
Yeah.
So and really, that's
pixel by pixel resolution as well, right? It's not we are limited by our perception when we look at object classification. Kind of when we look at a coffee mug, we see the whole object. But if you were training this image recognition model, it's stepping through it almost, pixel by pixel, and so it may pick up on features. You're mentioning medical imaging and diagnosing, or sorry. helping to form a prediction of whether this cluster of cells could be cancerous or not. It's not looking at it the entirety. It's very quickly going through line by line, pixel by pixel, and making decisions. Whether this looks like something or not.
Yeah, you're right about that. And as much as that is a blessing, there's a potential issue that we're facing with when we're putting this on micro hardware that we're going to do with the V-board. So that's something that we're working on now, to give the enough pixels for it to actually work with. When the image has 20 pixels, it's not, or like 20 by 20, like that's a bit better. You have 400 pixels. It's still not a lot.
Still, that amount of data to perform the task locally on a microbit, and then upload it to the cloud. That's a great mathematics problem for a middle school student. A 10 by 10 image is terrible resolution, but the level of data that it has to process is exponential.
Yeah, and like you said, it's a great mathematics problem too. Like they really get to understand what they're learning in the math classroom, like how it's useful in the real world. And of course, in machine learning, it's tons. And I think really, when you're learning, calculus in high school, I think this is really something that the chain rule is so important here. That I think if people just learned about machine learning, like maybe did a project of it in middle school, or have some background to it, like they'll understand why the chain rule is so important in calculus and other things. I mean, linear algebra, eigenvalues, eigenvectors are key in image recognition. But I think that's just with building any project. You end up learning a lot of things. It's really like mixing the salt and vinegar. One of which you get by learning the theory, and another you'll only get by doing hands-on stuff. So I guess to carry on with what I had planned for today. What I ended up, talking with Jeff about this experience, how while it's great that we were able to give students a bit of background and create some cool stuff with machine learning, what we really would love to do is if we had the ability to turn machine learning into something that's just as accessible as Scratch, or as accessible as writing very basic code, or just 3D printing something. Like they can manipulate everything, and they know the sky's the limit. And the biggest roadblock we had to that was the fact that right now, if you want to do something in machine learning, you pretty much have to do it in code. You have to do it in Python or R or MATLAB or some other thing. There's no way around that. And so we're brainstorming ideas, and the possibility of having a plugin, so like our own type of block from Scratch that essentially allows students to use machine learning as a block. I think that was something that really intrigued us, and we want to look into it further. And with some exploration, I came up with a couple prototypes, and this is one that I want to show you today. So essentially, as you all know, Scratch, you have all these blocks that enable you to do stuff, to code essentially. And while these are great, and they enable a lot of applications by themselves already, and that's another thing is the fact that Scratch, everyone, I think we have a lot of reach with Scratch nowadays. A lot of students, pretty much everyone that's interested in this kind of stuff in middle school, they've heard of Scratch, they've tried playing around with Scratch, and some of them are great at Scratch. And so if we can add another toolkit to an arsenal that they are already quite familiar with, it just takes very few, it doesn't take that long to familiarize themselves further with it. And the thing is, it's not just about building a machine learning application, it's also about doing it, like there's so much possibility when you put it into the context of other things. It's like we give them like a whole set of vocabulary to form sentences with. They can build this for anything. They can play a song when something happens. They can make the cat dance when something happens with machine learning. So it really opens up the possibilities more than just saying whether it's a cat or a dog, or whether it's an apple or a banana. So I'll just show you how this works. So like you've seen here, you have all these different additional blocks, extensions you can add in Scratch. So we've created our own machine learning. And by the way, this is on our oh wait, I have to turn off my camera here for this to work.
Peter, while I'm getting this set up, I'll share the link for anyone who would like to try this out.
Yeah, it's only on our own version of Scratch that we developed off the fork they had on GitHub. So yeah, it's not, if you just go on the main Scratch website, you're not going to see that. It would be great if they can add it as a real thing, though. You have to give it a second.
Yeah, no worries. So the example that Peter showed us, internal to Brilliant Labs, and maybe, are you going to go through rock, paper, scissors?
Yeah, I guess I could. That's
okay. Sorry, maybe you had something, crazy.
I mean, I don't know. I could like take an object from my desk and do that too. But you can talk about the example. Yeah.
Cool. So this idea, and I was excitedly explaining to Tasha, my wife, when I was seeing that video for the day, what if a student could design a machine learning enabled version of rock, paper, scissors through the use of the webcam block in Scratch? And so let's imagine a small local sample of data first, and you're training just inside your classroom. So maybe you have 21 students, 28 students, and each of them is showing an example of paper, scissors, and rock. Well, in the heat of the moment of the game, the orientation of the rock, the paper, the scissors, it can be in 3 different dimensions, right? Like there's a lot of different variation. And then with one person that I could give, maybe there's only half of the rock showing behind their head. Well, would there be a way that we could develop an algorithm to collect all of those instances that we claim are rock and extrapolate that and start to notice some trends, and as Peter mentioned earlier, that machine learning, it looks at everything on a very small scale. It looks for features. And so perhaps while we see rock, it sees a collection of knuckles and things like that. But then, 28 kids can become 600 students across your entire school. And then, of course, rock, paper, scissors can become something much more significant. And anyway, it looks like you're ready there, Peter. So
I'm just getting some things ready. Yeah, I'm just gonna do this like clicking on the scratch blocks, the easiest way to show this. So I guess to put that into visualization, example would be if we wanted to create a rock, paper, scissors game, or I guess it would be a game because the machine would always win if it knows what you're giving. But if you want to do a rock, paper, scissors recognition thing, so it recognizes if you're giving rock, paper, or scissors to the webcam, we can do that here. So I'll just let you guys see through this. So this is train label 1. Okay. Yeah, it's taking a while to train. Okay, so that's train, and I'm just gonna do that a couple of times. So this is rock, right? I'm holding a fist up to the screen, and so I like to do.
As you're rotating it, you're double clicking on that training label, and I see the machine learning that variable counts increasing every time that you're doing it. So now it knows 13 different versions of that rock. Is that right?
Yeah, and I like just rotate it to like, there's like big, small.
That's so
and yeah, it doesn't. You can train it like 100 times if you want. You can train like 5 times. I think it works if you do it 5 times. That's fine. Like I said earlier, it already knows some features. It's not doing it completely from scratch.
Right.
That would take an extremely long time, and that's why people were like, back a few years ago when we didn't have like this kind of advanced data sets and pre-existing features, like we had like hundreds of thousands of pictures just to train something, which was crazy hard to, obviously, for anyone, or like not to mention students, to set foot in machine learning. But yeah, now that we so this is going to be scissors. Yeah, but now with this, really, I like to do it like 20 times, but you can really, I'm pretty sure it works when you do it like 3 times. So it's not, for something like this, right? Rock, paper, scissors, like you can kind of tell the difference between the 3 pretty easily. For something more sophisticated, for example, and requires more parameters that you need to customize and manipulate, that's going to be a bit harder.
It makes me think of all that data that Google is collecting every time that it runs a CAPTCHA, and you have to select the mountains or select the traffic signs or select the cars or the buses.
I actually never thought of that. But I guess, yeah, they are probably training that based on the correct answers, and yeah. Okay, so I guess we can try it out now. If you hold a fist up to the screen. Oh wait, I'm turning classification off. Sorry. So see, now I think I see this. It's a bit small.
Yeah.
So now I'm holding up a fist to the screen saying 1, which if you guys remember, that was rock. And scissors is gonna go to 2, and now paper, that's gonna be 3. And just to make that a bit more visual, because right now, like 1, 2, 3, like you're gonna forget after a while. You're gonna like, wait, what's 1 again? So let's make the spread. So yeah, obviously, like I mentioned before, this works with the rest of Scratch in the sense that you have kind of like these things that are kind of like broadcasts when receive this, and you can append any block to it. So it gives you a lot more possibilities than, say, just just telling you whether it's this or that. Like, what, you can't really make any applications with it. So yeah, but I mean, obviously you can do that. Like, if you were doing this completely in code, you have much more freedom. But we're we're expecting that in most.
That is awesome. I'm just thinking of the applications and thinking about different what students have done in the past. You know, even Scratch is used as a coding language to run MBots. You know, to run all these different little robotic platforms, and so you could set up this this robot that is controlled by image recognition. And right now it could be driving around the room based on what it sees, but not only what it sees, you know, the data that is collected over all of these training. Look at that. Oh, it just thought that the
It
rock
actually
was paper.
wasn't working so well when I had my entire handout. I think it's just, especially between paper and between paper and scissors, having some trouble. So I think we might need to train this a bit more, for example, for it to work better. But it's doing it mostly fine. Yeah, for the most part.
That's cool.
You know, and what you could do is we could you can train another label.
So Peter, could this be collaborative in that if a student shares or saves this project, you know, once it is on public servers and they can really play with it, let's say that they're sitting at home and they're like, all right, I want some more data sets. Can they send the link out to their friends and they can train more instances of paper, rock, or scissors?
Yeah, for sure. That's a function that's very important, and I'm gonna show that later. But
Cool.
Let's try something different. Like for this is gone, so like I'm gonna train it away. I'm gonna turn it off for now while I train stuff, and I'm gonna enable 4. So, and you can have like you can like, you know, you also have, yeah, I guess you can do this, right? Train label gone.
Okay.
Yeah, but you know, I'm just gonna so I don't know what to do if I just do 1, 2, 3, 4 because I'm a numbers guy. But,
Right.
Here, how do I? Oh wait, no, that's not counted. Yeah, so yeah, there's no way to display that, unfortunately. I guess we'll just get rid of that just so it's easier for us to see how don't have that here. Just so it's easier for us to see how many counts of that is here. Let's try that a few times. I mean, this is pretty different from like rocks. So like, okay, that's probably enough. So I'm just saying you could do this with. Wait, I didn't click on it. Yeah, I'm just saying you could do this with anything, right? Rock paper scissors just in like anything that you could hold up to the webcam. Oh wait, 4. Yeah. So I'm just saying there's a lot of possibilities of what you can do with this, and also it doesn't, you know, we have the function for it to classify not webcam images, but images like actually on the stage right now, like on your Scratch screen. So I'm gonna turn the video off so it's easier to see this. And what I'm gonna do is yes, hidden here. So let's say you can like draw something, or you can like upload a file. Pretty sure in Scratch you can do that. So let's draw and let's draw. What do you want to draw? Let's draw the purple. Wait, here, the purple G for George Street. Yeah, if you want to go ahead and hide, I can delete this guy, but let's hide him, I think. Yeah, let's hide the cat. Now we can do is, yeah, let's make it count 5. So now we're classifying images that's actually on Scratch, which I mean, pretty much anything you can think of, you know, any image that's on your computer, or you can draw it like I mentioned. So yeah, so I think students are very familiar with how to do something like this, and they could make very complicated. Just think about like the intricacy of programs that could be made with this. The changing backdrop, for example, that changes every few seconds, or changes when you press a key during a game or something, and have this run automatically in the background to learn different stages. And you know, I'm just saying it could be some very intricate logic in there, and that could create some really interesting applications. So I'm gonna oh wait, I mean, I guess it's the same thing, so you only need to train it once. I don't know why I click on it so many times. But now, yeah, so now we can, the current AO is 5, as you see here. And what we can do is, so let's say if we want, when we show the cat, this is going to be a different label. So like label 6. Yeah, and now it says 6, but when we hide the cat, it goes automatically to 5 because the picture isn't the same anymore. So I'm just saying the picture could be digitalized. It doesn't have to be the webcam. So they could add this into any of their Scratch programs, and you could recognize whatever game they're showing on their screen or an animation that they're showing on their screen. That's a possibility as well. But yeah, definitely a lot of possibilities with just the webcam too. So I'm going to show that thing that Jacob mentioned earlier with downloading and uploading the learning data. So here we have these 2 blocks: download and upload learning data. And so right now, the thing is, because this isn't real Scratch, so we're expecting that if they work on something, that if they want to use it again, they definitely need to have the file, assuming that they're not staying on the computer for forever. So so when you click on that, it downloads this as a JSON file, and a JSON file is pretty much like it's a type of file that we use for data for storing data, and it's I guess it's very similar to, let's say it's just a bunch of object files. I guess you could possibly visualize this in like Excel if you wanted to, but yeah, so that's the JSON file, and that's what you need to, like, when you want to upload. I think I had it down. Oh, it's right here. Yeah, so you just upload that and it's gonna work. But I already have everything here, so I'm just saying I could send this file to any of you guys right now, and you can continue using the model because it's gonna have everything set up.
Oh, cool. So we could continue building on that data set of iterations of rock, paper, and scissors, and then come up with a more robust data set for recognition.
Rock, paper, scissors, gum, and that purple G.
And the purple, right? Very cool. Well, the time that we have left, Peter, I'm wondering if we can dig behind the scenes. Sorry, do you have another feature that you wanted to before we talk about the keyboard?
Like when you upload it as like.
Oh, okay.
Like but yeah, and I can recognize stuff. But I'll save some time and we can move on to the next thing.
Yeah. So we're on this journey with the B-boards, where we're really hoping that students are able to harness the IoT potential of the B-board with the onboard Wi-Fi, and then collecting sensor data, and really being able to understand the data that they are collecting across a larger geographic range. So for instance, what if Brilliant Labs operates in all throughout Atlantic Canada? X number of students, say 1,000 students, have access to a B-board, and they're all collecting similar data. Well, what types of trends are they able to notice through the use of machine learning in analyzing that data? And what's more, what kind of intelligence might they be able to integrate into their projects based on data that's captured over a larger and larger data set? So Josh Keys and I, we get lost in this conversation. So there's a project for teachers who are interested. Keep checking in with Brilliant Labs over the next few weeks. But hydroponics are super popular for our project funding portal. And well, what if we could develop a machine learning enabled algorithm for students, for educators to know when to turn those pumps on, when what brightness levels, just that your lights need to be to optimize growth value. And what if all of that could be done based on image recognition data that's captured by a camera and fed through our code so that we just get more and more examples of the plants at various stages. Arguably in different provinces, different environmental conditions will cause leaf growth to be different. How can we capture that variation and begin to understand plant growth better across and all with block coding? And allowing students the ability. Peter, you mentioned another tool in their arsenal. I think that is awesome. I'm not sure what kind of information war they're going to wage with this arsenal of tools, but it's pretty exciting to think of.
Yeah, definitely. And the project that we mentioned a bit throughout the thing with getting this onto the B board, which some of you might have heard of. I think that's really going to enable them to, because coding like this is cool and all, but I think when you're like a kid and you're able to like play around with something that's in the real world, like that you can like touch, that you connect the B-board to a camera and you take a picture and like boom, that's uploaded as a training data, and the next time you scan something similar, maybe you took a picture of, like you said, maybe it's the plant growth, right? You took a picture of plants and you take it to, you actually go out to the real world and you take pictures of plants, and then it's able to show you just on the B board or like through a display, through that thing on the LED on the microbit or something like that, which stage of growth this plant is in. Like just doing like even a project like that is going to, I think both it's going to be really fun, and also it's going to, just from the learning perspective, it's really going to ingrain that into their minds so much better, and they're going to have that curiosity to go out and play around with stuff. Because I know for me, that's a big thing for me. Like when I first, when I first got like it was like a circuit kit where you can connect light bulbs with like stuff like that. Like that was huge for me. And yeah, and even now, like programming, whenever you see a way to connect it to hardware and see it actually like happen like in the real world, I think it's a huge move. So yeah, that's definitely something exciting that we're working on, and hopefully we'll be ready soon. But in the meantime, I think the Scratch platform discusses with Jeff as well. I think Jeff really likes this, and hopefully you guys all do. And we think this has a lot of potential to be, to host some potential events within Brilliant Labs where we have maybe like a Scratch machine learning hackathon or a competition where you build with Scratch machine learning, or with just a project that uses any other blocks as well, maybe a game that uses machine learning. Imagine how cool that would be. Because we have Scratch. I remember we had those when I was even. We had these competitions, right?
Yeah.
And
Still to this day.
Yeah, and imagine there was a game that learned, like you had a weapon or that you would shoot in the game, whatever, that was created based on machine learning. Like you point to 3 things and it learns that. So that would just, I think that's the possibilities are endless even now, like even in Scratch. Once you do move it to the B board, I think it would be within MakeCode, which is the the language that we're using, or like I guess the website, the platform that we're using to code the B board.
Yeah.
But this is gonna stay for sure, and we're gonna do whatever work is needed to maintain and develop it. So I think if anyone's interested in possibly using this with students at the beginning of the next school year or anytime, I think it's can definitely contact us and we'll have that set up and happen.
That's awesome. Let's turn the floor over to our participants. Any questions for Peter about the applications of machine learning in Scratch, the possibilities of student connections?
I'll take a look at the chat. Oh, they can talk, right? They're not.
Yeah, that's right. You can unmute the microphone. That's right. I didn't see any questions come in if we scroll up. These sessions are recorded as well, and so you can go back and check it out. And as Peter mentioned, please get in contact with us. we haven't done a lot of work with machine learning up until last year. We do have that module. I'm not sure if all of you have checked out learn.brilliantlabs.ca.
I
There,
made that too.
yeah,
But that's more of I guess I meant it more for, because that's what I mentioned with using real code to do
yeah,
machine learning,
yeah.
which is cool, like I said. But I think it would be phenomenal if the students had a bit of green to like green field to coding, as if as in they know maybe how to write a bit of JavaScript or whatnot.
Absolutely.
I think they're gonna just harness the tools a lot better than than if they didn't know anything beforehand.
Yeah. On the teacher side as well, we're becoming interested in finding the time to be selfish with the technology that we use with students within Brilliant Labs, and look towards machine learning to see what nuanced information we can gain about looking through all of our project applications over the last 5 years. They are all somewhere. And so one of the things that kind of interests me with machine learning is sentiment analysis, understanding keywords and the similarities, behind what would have to be maybe 2,500 applications over 4 provinces. Training an algorithm. What kind of nuanced information or knowledge could we learn about our own practices? And whether that's a really neat data visualization through a word wall or something like that. It would take years for us to collate all of that data. It can be, it's pretty powerful. So hopefully we find some time to look at ways to turn machine learning inward to help benefit our maker educators. What do you think, Peter? Should we leave it there?
Yeah, I think that's a good place to leave off.
All right.
Yeah,
Well,
the link is in the chat if anyone wants to continue to try it. So I'm gonna
yeah.
leave this for a very long time.
And many thanks to you, Peter. You're an incredible example of how we are not even beginning. We have every year more students who have been involved in Brilliant Labs affiliated projects in their high school or middle school experience. Not only reach out to say hi, but reach out and take our organization to new frontiers, and it's pretty crazy. So thanks for that, Peter.
Yeah, I'm trying to get the right camera here. Yeah, I guess it's my honor being part of the. I was part of one of the first Brilliant Labs cohort. I remember back then just like getting stuff set up. At North Street, just had a small maker space. Really glad to see the growth over the years, and obviously this is paving the way to the future. To have kids to actually be curious and play around with these stuff. And one thing I like to say is, it's never too young. You have people that think, oh, it's too young to learn programming at this age. That's something 20 years old do. You graduate and you do that as a job. But really, like, if if you don't want to, you don't see it as something that you need to learn or you have to learn, and rather as something that's interesting, which I think we all have as humans. It's just natural ability to have curiosity, to want to explore the world, explore new knowledge, new things, create things. I think it's definitely a great a great joy to be working with and making these projects.
Peter, you present an argument against age-based classrooms and age-based learning of any kinds. It doesn't matter how old we are to be able to dig into any topic at any level of significance. You got her. Well, thank you very much.
Well, thank you both.
Yeah.
Peter, good to see you again. Jacob, always good to see you, my friend. And thank you to Brilliant Labs for once again coming through for LearnEast. 4 amazing sessions today, all with some really cool learning attached, and things that teachers can use at somewhere in their classroom, pretty much anywhere. So I'm going to stop the recording. If people want to sort of hang out and chat, that's great. But just a reminder that in about 10 minutes, we're going to meet in the final session. Don't forget on your way out to fill out the form, get your name in the ballot for the final, for the draw, for all the great prizes. many of which, or some of which at least, are brilliant labs. You could win one of those amazing B-board kits, and there are 4 of those, I believe, on the table. So thank you to Jacob for that, and to all our other presenters and all our other sponsors as well. So